Hi there, everybody. We'll make a start now. Thank you for your patience tonight, and apologies first of all from our PWI President, Mark Harris. Unfortunately, for personal reasons, Mark couldn't make it tonight. So I'm Neil Hobden. In my day job, I'm the Director Track with Transport for New South Wales. I'm also part of the subcommittee for the technical meetings. So Mark's asked me to chair the meeting tonight. So thank you everyone for coming, and we'll make a start. Tonight is proudly sponsored by Effective Rail, and I think it's fair to say for me coming to these events, it's the most people I've seen from one company supporting the sponsors. So great to see all you people here from Effective Rail tonight. And we'll also have a second talk from Mike Hickey. I'm sure most of you know Mike, later on electrical traction. So thank you very much to those that are coming and presenting tonight. So welcome. This is the team. So Mark Harris is our president, as I just said, and myself, and then Praf. We form the technical meeting subcommittee, and we try to put together an informative collection of meetings and papers during the year for our members. First of all, I wanted to start with an acknowledgement of country, and I thought I'd change a little bit and talk about my children and the fact that my children are dual nationality. They're Hungarian, British, not yet Australian, and recently they went away on a Hungarian scout camp and they spent some time up in the Putty Valley, and I thought I would pay my respects. I don't know why it's not come up to say that, but we're missing a part there to say we're paying our respects to and I can't say the speech and I apologise, but I've lost my train of thought here now, so I'm going to say what I've got now, and apologies. So the campsite was located in the Putty Valley, which enjoys a unique location, and is surrounded by the Woonami and Yango National Parks. And the valley was home to the Darjung Aboriginal people who died out in the 19th century from disease disposition. And it is thought that the name Putty was derived from the Aboriginal word which sounded like booty or parbuti and means a place of plenty. So, as I said, we pay our respects to any Aboriginal peoples, past or present, that are here today. Thank you for that. So my new format didn't quite work there, so I apologise for that. We'll get that cleaner for next time. So, agenda is the standard running today. Welcome, safety briefing, presidential update, some information on future events, member update, and then we're on to the main presentations. Then, as usual, there'll be a wrap up and some time for networking at the end. So just to give the quick safety briefing, which I believe is just I'm sure everyone must know. I think the main way is to come out of here, down Castle Reach Street, then Castle Ray Street, apologies, and then through to Hyde Park. I'm struggling here to actually read from the lectern back to the screen, so apologies there. Apologies, new members and guests. So if you've got any new members here, it'd be good to see any hands up for those who've not been to an event before. I say apologies to Mark and for many of the committee today who couldn't make it. I know that Stuart Sutherland's here from the committee today. I think we've got a few from the committee here, and obviously we've got Natalie who's supporting there with the arrangements. So thank you very much for support. So, President update for today. First of all, a thank you for those that went on to the Tullawong High Voltage Substation tour. I understand it was a well represented event, and those that went found the event interesting. Whoops, apologies, there's some pictures there from the event, and it's good to see we're getting site inspections and site visits done now, both for track and for electrical, and we'll carry on trying to get together some more site visits during the year. One thing we're probably guilty of is making sure that we give our members enough notice of where those site inspections or visits are. So that's one thing we're working on as a team, just to try to give some more warning so people can put it into their diaries at an earlier date. This is some shots from the recent Golf Day. I don't know if any people here made it to the Golf Day. Again, I understand it's a successful annual event. Thanks to Wade for arranging the Golf Day, and I understand we have a Golf Day already arranged for next year as well. So if you couldn't make it and you enjoy playing golf, please think about the golf. I think it's around the same time each year for next year. I'm going to have to stand closer to read this one. So yeah, thank you to our sponsors. We have 2 mini prize winners to list, and yes, there are awards on each hole. and for novelty events, the longest drive and nearest to pin. Special mention needs to be made to the following major award winners. Handicap team results: first place was Breffney, second place John Holland, and third place RPS. And then the scratch team results were Breffney again, Aaron Co, and RPS. And lucky last was Smek. If anyone can explain what the lucky last was, that would be good.
That's the Bradman prize for the highest score.
Ah, the highest. Oh, right, okay, makes sense. Yeah, okay, all good. So yes, as Wade said, looking forward to seeing you all again next year for another great day. So thank you for those that made the golf day. This is a really important slide for the PWI, and this is about encouraging our young achievers and looking for young achievers to be put forward for the award for this year. So this is a call out really to any budding engineers, and both for track and electrical. If you're under 35 years old, are a financial paying member of the PWI and have an amazing project that you've worked on you would love to share, it'd be great to see you or yourself encouraging members of your team to apply with a submission. There's still a couple of weeks. The closing date's the 12th of May. Fantastic kudos, and also fantastic prize to win, which is $10,000 towards attendance at an international conference. And from what I understand, it's usually a reasonably well supported award, but we'd like to always see more people put in for it. So yeah, please do discuss that with anyone on your team that you think would be able to apply for that. Technical meeting sponsorships. Unfortunately, the formatting's not quite worked, but this is just to say we've got meetings still coming up later in the year where we're looking for sponsors. So this is opportunity, such as we've got Phil from Effective Rail today with his team, who'll come along to present, and we're looking for the same later in the year. The events are heavily subsidised still by the PWI. We believe, again, the formatting's a bit out, we apologise for that, but we believe the event is a good opportunity to provide advertising. We place details on our website and on LinkedIn, and the sponsor provides the core event presentation. So if you're interested in doing that, please reach out to a member of the committee team. Thank you. For the next slide, I'm going to have a break, which I think I need, and hand over to my colleague Stuart. Thank you, Stuart.
Yeah, good. Thanks, Neil. I just wanted to announce that we have another cadet, PWI cadet. So a fellow called Liam Clowes, who's from Hunter Valley, finished Hunter Valley Grammar Year 12 last year and had a terrific ATAR. What we have done with the program is really marketed towards schools. We're trying to get the new crop of engineers in their first year into the program, which Liam is that. So it's great to have Liam on board, and we've got 3 cadets running through the program at the moment, and I think Declan McClary is here as well. I think the measure of success is if anyone talks to Declan, I think you'll see that the program is working very well. So thank you. But yeah, that was an update. What I would like to ask is companies, member companies of the PWI, if you could be available to potentially host a cadet over summer vacation. We'd like to provide rotation. So anyone who's interested in providing a different experience for our cadets, please come and see me after this.
Thank you.
Good. Thanks, mate.
And good to see you here tonight, Declan. Thank you. So future events, these are believer in chronological order unless they've been moved around. So next one is on the 10th of May, and it's our executive breakfast. This is an event that's reserved for our enhanced and corporate members, and it's a great opportunity for networking and engagement with the industry leaders. Our keynote speaker will be the Chief Commissioner of the Greater Sydney Commission, Jeff Roberts. He'll be providing a presentation on New South Wales's 6-city strategy, and that will be followed by an interactive Q&A session. I also understand there'll be a panel session to follow that, although the speakers for the panel are not yet been finalised, so that will be put onto our website as soon as possible. I know that emails have been sent out to the corporate companies in regard to the executive breakfast. I know there are still some places available, so if it's something you're interested in, please do have a look at those emails. Thank you. It should be a good morning. Our next technical meeting is our combined technical meeting, so that'll be the first one for me to work with the RSC on. So the corporate presenter will be WSP for this event. They'll be providing at least one, if not more, presentations to cover track signalling and electrification. And we're also looking at a further technical presentation in the new format to go with that. At this stage, that can't be confirmed, but hopefully it will be an interesting presentation which will complement the main one again. And after that, we have the PWI Winter Dinner coming up. So these events coming up fast now. So 16th of June. And we invite our members to the Winter Dinner, which is proudly sponsored by John Holland this year. Please bring your partners and colleagues for an evening of fine food and drinks, great entertainment, and a chance to catch up with all your rail counterparts at the Whiskey and Gin Bar. So yeah, I'm not sure the tickets are available for that event yet. I think, oh, they are. OK, I've just been updated. They are available. So I assume that's through the website. If you're interested in attending, please have a look on our website and sign up accordingly. This is one that I'm hoping to arrange later in the year. I think it'd be really good if we can do a site visit out to Parramatta Light Rail construction works. So looking at doing that at some point. We just need to make sure it's the right stage of construction where we can get on and not cause disruption to the programme. I had a conversation with the technical director today, and hopefully we can look at doing that later in the year, September, October time, hopefully. So it will be limited numbers due to the site constraints. Once we know, we'll advertise that accordingly to the members, and it'd be great to see some of the members at the event. The big one coming up is our annual convention. This is the one where we go regional. So this year our annual convention will be in Orange, and there's two things to say at the moment. One is, I believe that we're arranging a train which will be taking members up from Sydney on the Thursday up into Orange, so that will be good. Be great. I think we've done that before when it went to Bathurst. The train was laid on, so it's really good to see Sydney Train supporting us with this event. And secondly, if you are interested in going, get your accommodation reserved early is the advice, because Orange doesn't have that much accommodation, so it's worth getting something booked now if you can and you're interested in coming along. We haven't got the full agenda to distribute yet, but I'm sure that Steve is working on that. We'll get something out at the fullest in time. And then after that, there'll be Ausrail Plus coming up, but this year is in Sydney for those that are thinking of going along to it. The event will be held between the 13th and 16th of November, and we are hoping to be able to run 2 technical streams for both track and electrical. That's not confirmed yet. We are waiting to review the abstracts which have been received by the ORA team and the finalisation from the ORA team of how many sessions we are being asked to manage. But we've asked for 2, one to cover some track and one to cover electrical talk. So hoping that's what we get. OK, a member update. So firstly, again, just to thank our corporate members, and in particular our platinum corporate members. They are John Holland, CPB Contractors, Acciona and Langerook, and to say there is one spare platinum membership available. I'll just run through the golds, and firstly, just to say thank you to JMDR, who have upgraded from silver to gold membership recently. We also got MP Rail, Brimble Rail, Middleton Group, Progress Rail, Pandrail, McConnell Dowell and Jacobs as our gold corporate members. There's also a couple of slides there for our silver corporate members, and to say we've still got 4 spaces there if any companies wishes to join us. And a new slide there just to highlight the range and the number of different standard corporate members that we've got, which is great, and the number of companies that support PWI is amazing. And on another note, the actual number of individual members that are supporting the PWI is great as well. We've actually seen almost a 7% rise since the last technical meeting. We're up to 351. We also have 8 retired individual members and 21 life members as well. So yes, great to see individual membership surging. If you know anyone else that perhaps not sure about the PWI, please let them know. Please encourage them to join accordingly. And for also those that have been signing up on the LinkedIn site, it's great to see that the LinkedIn site's grown in our membership. I think at the start of the year, we were around 800 members on the LinkedIn group. We're now up to, I checked today, over 1,300. So it's really good to see a growing following for the PWI New South Wales on LinkedIn. Okay, we're starting to get closer to the presentations now. So the main one today is by Effective Rail, and really pleased to see both Phil Scott here as the General Manager and Peter Long and his team. And it's great I think for them to be able to present on the technology they're going to show us. There's a photograph there. So they'll be presenting primarily on the benefits of using the McCulloch range of plant, which is delivering projects across Australia, whilst also giving an overview of their company as well. So Phil joined Effective Rail as their General Manager in 2021. And prior to this, he worked for Sydney Trains Major Works as a construction manager in their track renewals programme. Phil's been involved in delivering several Clearway projects, Rio Tinto's 365 rail expansion project, FMG's T165 rail expansion project, and as well as various rail and civil projects in the UK, such as the Channel Tunnel Rail Link, Network Rail Station Access, and TPWS programmes. Peter Long is a Chartered Civil Engineer with the Engineers Australia and the Institute of Civil Engineers, with 20 years experience in the railway, highway structures, civils and utilities environments. He has worked on major stage projects in the UK, including Waterloo Station, King's Cross Station and St Pancras Station, as well as projects such as the London 2012 Olympic Games. So as far as questions, not sure, Phil, if you'd rather take questions during the presentation or at the end, or... Okay, that's fine. And for those that are online, I believe you can post your questions in the chat and then we can relay those questions to you at the end. So we'll hand over to you now, and thank you very much to Effective Rail. So.
This one, Neil. Backwards. Just switch backwards and forwards.
Forward, backwards. That's it.
Backwards. Right. Okay.
Loading up the presentation to the second one.
Okay. Good evening, ladies and gentlemen. First of all, I'd like to say thank you to the committee for being invited along this evening to obviously speak to you about the benefits of using the McCulloch range of equipment. Before we get started, as most of you know, today is Are You OK Day. Now, I'd like to ask everybody here to take time out at some stage, either today, tomorrow, following few days, to actually talk to your work colleagues, your friends, relatives, start a conversation, ask them if they're okay. If they're not okay, then continue on the conversation with them. Yeah, it's in this day and age, even if you're not okay, it's actually okay to put your hand up and say so. Best thing to do, you start the conversation and continue it on. So just going on, just some background on Effective Rail. So Effective Rail is a part of the Effective Services group of companies. The rail division has been operating since 2015 and is currently based out of its Campbelltown office. Up until a couple of years ago, the rail division was predominantly a brownfield rail maintenance outfit operating within New South Wales. Over the past 2 years, Effective Rail have expanded its outlook into the rail infrastructure industry, not only in New South Wales, but also in every other state in the country. With projects from Cairns to Karratha, Adelaide and Melbourne, we are now pushing the Effective Rail brand nationwide. One of the things that sets us apart from your normal rail contractor is our unique fleet of McCulloch's rail handling solutions. Having one of the largest fleets of McCulloch equipment in the Southern Hemisphere, we can provide modern solutions to the Australian rail industry, which has never been available before. So a little bit about the origins. McCulloch Group is a Scottish-based rail engineering company, which has been around for almost 30 years. They started as a rail infrastructure company, but moved into making and developing bespoke and patented machines that eliminate manual handling, improves productivity and safety, whilst also reducing the risk. The owners, Billy and Danny McCulloch, who were the driving force throughout the early days of developing the TRTs and the panel lifters. They've gone from having concept ideas and outline designs to now utilizing modern technology with computer-aided designs to build machines that are changing the way the rail infrastructure works and is delivered around the world. So some of the industry challenges for the TRTs and panel lifters. I joined Effective Rail back in 2021. My previous role with City Trains, I recognized there was a market for these types of machines that can improve safety, especially with people and plant separation, manual handling, obviously coming in as a major improvement factor. The drive for innovation to inject new ideas and methodologies into the industry, doing more with less, and the idea of potentially working on the live overhead wires during shorter working windows. Effective Rail got involved with the McCulloch product back in 2021 when we obtained our first 2 TRTs. Having one of McCulloch's subject matter experts and trainers on board helped us massively with our training with our first group of TRT operators. Our very first opportunity came several weeks later in the form of a request to install a couple of rails from Sydney Trains in a single line tunnel within Sydney. A long story short, it was our first outing. From start to finish, the first rail took 1 hour and 15 minutes to install. It wasn't the best. But having learned valuable lessons from moving the first rail, we applied the same principles to moving the second rail. So much so, the second rail was actually installed in 4 minutes. Training is all well and good, but it's when you're faced with dilemmas in the field that you learn the most.
So the track rail transposer is an extremely versatile machine. It's been used in the UK for the past 15 years and is now in the Australian market. It's been used to transport rail and remove from lengths of from 6 meters up to over 400 meters. So one of its key features is that it can operate under live overheads. This is a great benefit because currently trying to get hold of power out permits at short notice or just trying to get the staff to help obtain the permits in the first place can be quite difficult. And it can also mean that you can do emergency track repairs at short notice, which we all know if there's critical repairs, you need to get them done. The other key feature about this machine is that it can work in restricted areas, tunnels, cuttings, platforms, single track. And this provides a great benefit along with its 3-ton lifting capacity, means that it's a real benefit to and advantage over traditional plant. It can lift anything from turnouts, different types of rail, switches and crossings. And with its rubber track, it means that it doesn't even need to go on high rail, it can just get straight on. So some of its safety features on the machine itself include remote operator. So you can see the operator there. He's standing away from the machine, so he doesn't need to be near it. In the dark, and you can't see it here, but you'll see it in later photos, there's blue halo lights providing an exclusion zone so that people on plant interaction is minimized. And it also has remote controlled operator grabs so that there's no need for the operator to get anywhere near it, just drop its grabs and pick up the rail where required. Some of the other key features about the machine as well, there's no slewing on this machine, it's not required at all. And the rail was held within the body of the machine, so it makes it much more stable. It can re-rail up to 3 kilometers per shift, which is quite a lot, and that's just a pair of machines. So if you operate more machines, you can do longer lengths as well. And it's more accessible than traditional excavators. It can climb on track and operate at 45 degrees, trying to get on track. Some of its environmental credentials as well, it meets the Tier 4 final, its engines meet Tier 4 final regulations. So it means it emits low emissions.
and it only uses about 13 litres of fuel each shift, which is a lot less than traditional machines. I'll now hand you over to Phil, who just look at some of the case studies for the TRT.
Thanks, Peter. Okay, we'll run through a few case studies just to give you an idea of what the machines have been up to over the past 12, 18 months. The first one I'd like to go through is at Enfield. So the scope we were involved with was the replacement of multiple stock and switches, crossings, various sections of re-rail and closures throughout the yard itself. We were approached by Sydney Trains to actually utilise the machines because they were unable to obtain a overhead wire permit for the works. Prior to the work taking place, Sydney Trains and ourselves recognised that it was the first time we'd actually used, or the machines were used, on the live power on the Sydney Trains network. So obviously they were asking for detailed methodology on how they're going to be used, where they're going to be used, and the capabilities as well. So having gone through detailed talks with them, we allayed a lot of their fears. The result, well, the scope was successfully completed, no incidents or injuries, and since then the work on the live power for TRTs has become a regular occurrence, especially at the time when the ongoing PIA was in place. Why did they approach us and why did they ask us to use them? Well, they recognised that there was a solution, a safe solution that we could provide. Next case study was a project we had down in Adelaide for Coleman Rail. The scope itself was re-railing part of the 20-kilometre dual track improvement. The issues we had, once again, there was no isolation permit available. We were tasked with moving 20 kilometres worth of 165-metre rails from stockpiles, which were placed 4 kilometres apart. And the possession durations meant we were working 24/7. And with the work being carried out on the live overhead wire, the TRTs were actually requested, it was specified by the client. The rail was not allowed to be dragged on the ground. So we actually used a system of rollers to maneuver the rail from its stockpile point to the point of placement. The rollers that we actually used actually come part of standard on the machines themselves. In some cases, the rail was welded into 440-metre lengths and then was actually changed out into the with the old rail, sorry. The result, while employing the correct methodology with the TRTs set up correctly, meant that on some of the shifts, we would actually re-rail up to 3 kilometres in a shift. Something that the Coleman Rail guys were actually impressed with us doing. Nope. Okay. There we go. Yep.
Oh, too far.
Yep. Go back one. Go back one. We will get there. Okay. So the last case study with the TRTs, this is a shot, as you can see. It's a tunnel job. It's the CYP Cross Yarra Partnership Tunnel. This is the new Melbourne Metro. The scope, well, was to move and install 18 kilometres of rail within the new Metro tunnel itself. So some of the issues that we actually had, obviously, as you can see, but from the photo, we had restricted access. With the tunnel being almost completely fitted out, we had to work around all the utilities and track furniture that was currently in place and throughout the platform areas. The TRTs will be working on a constant angle owing to the precast panel guardrail design. As you can see in the centre to the bottom of the picture, where you'd normally or traditionally get your guardrails in the forefoot, the design had concrete upstands instead of guardrails, which proved difficult for other machines, but for the TRTs, they can work on an angle. So how did the TRTs excel themselves? Well, we started off initially with 2 of the machines, plus the client had 2 of their own rail threaders. After a week of working, we were asked not only to double the number of TRTs, but also start working around the clock. Once the extra TRTs appeared on site, the rail threaders were quietly placed to one side and were not used again for the next 5 months. As a result, well, we managed to install the 18 kilometres of rail in each tunnel safely, efficiently, and to the client's satisfaction.
Just move on to the next slide. So the panel lifters, you can see in the background photo. So these are extremely versatile machine, been used in the UK for the past 10 years. And proven themselves to be across Australia as well, which we'll show you in the next case studies. Next slide. So the panel lifters themselves are similar to the TRTs. Again, they're rubber tracked machines, so they're accessible across all different parts of the track and shoulders to get on. And they're also remote controlled again. So again, people-plant interaction, keeping the person away. And again, the rail or the panels are again lifted from underneath the body, so keeping it safe away from people. So there's no slewing involved again on these machines. Each of these machines can lift 9 tons. They work in pairs. So working in pairs, they can lift about 27 meters of panel in one go. They're various sizes as well, means that they can also work in single and multi-track layouts. Next slide. So on here, the machines themselves, with their adjustable height and width, they can operate in any type of different types of track or turnouts. So in that background picture here, and there'll be a video in a minute, is of the Sydney Gateway, where we picked up the panel and picked up turnouts and there was various constraints as well. And you can link different types of link multiple machines together, so you can lift multiple lift longer panels. You can also adjust the lifting mechanism on the bottom as well to have different types, and you can end up lifting larger panels or wider panels or turnouts, etc. But one of the main key benefits about this machine is it provides more time for possessions. The way it does this is that it can just pick up the whole panel or in sections of it, 50 meters or even longer, pick it up, remove it, and buy more time for the possessions. And we'll see that in the next one. And it also means that you reduce the amount of plant and labour as well. We'll just look on the next slide. Oh, no. It should play a video, hopefully. Maybe. There we go. All right, so this is the Sydney Gateway itself. So the scope of works here was in order to clear the track as soon as possible for the plant. For the drainage works to occur. This was in the Boral siding. That Boral siding is one of the busiest in New South Wales, if not the busiest, and it had a very limited window in order to operate. So we was called in to come up with a solution in order to give them as much time over Christmas. And we went in, and with 4 machines, this one was just lifting up a single track, So there's only 3 machines, but we also used 4 machines to lift the turnouts. It was also next to the Sydney Gateway Airport, so there was restricted airspace. So using cranes to lift out whole sections of panels wasn't going to be feasible. We managed to complete this task on time and to the client's satisfaction, and they were very pleased because they basically had loads of time left over and we got it back in.
Okay, the next case study was multiple track reconstructions in the Pilbara. As you can see from the photo, some of the issues we had, we were in confined and remote working areas with limited access points. The adjacent line had to be kept open to rail traffic. We were using unproven methodology for the client. So we actually sat down with the client themselves, developed the working methodologies, which involved no slewing for both the panel lifters and the TRTs. The result meant that the adjacent line was kept open for bidirectional running throughout the close down. So the client was able to push ore to the port and empties back to the mine. This was the first time this had ever been achieved for this particular client. The increase in production from the previous maximum of 300 meters for a recon within a full shutdown, well, we stretched it out to 800 meters per shutdown while we were keeping the adjacent line open, which meant the ore keeps flowing and we don't stop the work. Okay, the next one is the Sydney Trains job in Blacktown, track reconstruction. As you can see from the video, this was the first time the panel lifters had actually been used on the Sydney Trains network. The client was skeptical on the speed of the panel removal and reinstatement. It was a new method of working, which once again was unproven to them. We also had trains running several tracks over, and obviously with driver perception, when the machines are working, that proved to be a sticking point at some point. For the actions, well, we talked through the whole operation with the client. We reassured them that we knew what we were doing. We showed them videos of previous jobs that we'd actually done. The result, well, we actually removed 3 track panels totaling 120 meters with guardrails, which were left in place in 16.5 minutes. We managed to change out the jewellery for them as well. When the panels were reinstated, the project was virtually a full shift ahead of where it would have been if they were using the normal methodology, which was a massive time saving for them. So once again, we had no slewing issues with trains running on the nearby lines. Now, just a few of the panel lifter stats I have for you as well. Prior to Christmas just gone, besides lots of training that we'd done with the panel lifters, we'd only had 96 hours of actual track time. Since Christmas to date, we've just had on 1,800 hours of track time with the panel lifters. It shows the uptake of what clients actually want and what they're willing to do. Slide, please. So some future innovations which are coming through. We have the TRT-E over the far side. That's an all-electric version of the TRT. That's actually been developed with the Williams Formula One team. It has the same duty cycle as the diesel model, plus a battery life that will deliver a 12-hour shift before it requires a recharge. This is currently undergoing field trials with Network Rail in the UK. The next, we have the TCT, or the Track Cable Transporter. It's got a 2-ton lift capability. It can be configured to carry cable drums, water cubes, weld crates. It can go anywhere where the TRTs can go. They actually call this one the Infinity because the possibilities are endless for its use. Next up, we have the 25-ton panel lifter, or the turnout solution. Each of these machines is capable of lifting 25 ton. It can accommodate larger turnout panels. It's fully remote controlled, plus they work in pairs, or as we call them, a set. Each set can carry in place a switch and crossing panels from the set into track. The tracks can expand out to enable them to remove turnouts from tilt wagons on trains. With multi-point lifting beams, they can keep up to a 1 in 18 turnout rigid when lifting into position, reducing the risk of crippling the switch. And it has minimal mobilization and demobilization times. Lastly, we have the MMPV, which is the McCulloch multi-purpose vehicle. I didn't name it. It's a self-propelled track vehicle. It can actually load itself onto track without the need for a high rail pad. It can go from a safe place in the CES to on track, fully loaded within 10 minutes and with a fully loaded payload of up to 40 tons. It can be configured for cable drums, vac units, crane arms, for closures, GIJ installs, scrap removal. The system itself is actually interchangeable and can even take welfare units as well if needed. Next slide. Okay, so now's the time that you can pummel me with questions. If I cannot answer these questions, there is a gentleman at the back end of the room there. He's actually one of McCulloch's finest that is on loan to us at the moment. If there's anything too technical, then he's the man that can answer the question. Obviously, if you don't want to ask questions here and now, then afterwards, when we're having some refreshments, then please feel free to come up and catch one of us and ask the questions then.
Delivering work in WA, how are you moving your equipment, sizable equipment to different states? Are you now basing yourself out of other states as well?
At the moment, we float them in and out. The project in WA, I believe the machines were over there for about 6 weeks. There were multiple close downs, one after the other. So it actually proved more economical to do that way. But the long run, ideally, yes.
Do these machines need to go through Australian work cover registration, but as a lifting appliance in Australia?
I believe the panel lifters are classed as a gantry system, but don't hold me to this. I don't believe it. Don't believe it. So I think Billy may be able to answer some of that later on.
More questions?
Well, if there's no more questions now, please. Oh,
No reason to deal with Entra, the regulator.
we haven't as yet. No, we've. But if they're here, we're only too happy to have a conversation with them. Not too in depth. Okay, thank you very much, ladies and gentlemen. Thanks for your time.
Thank you, Phil and team, for that presentation. I thought certainly very interesting, and I've been aware of their technology since they've been here, and the McCulloch work that I worked back in the UK. The sort of sites there, moving rail on now is very impressive, I think, and I'm sure the work will only continue to grow. The next presentation I'm going to hand over to Mike Hickey is on electrical interfaces. So thank you, Mike.
Good afternoon, ladies and gentlemen. I'd like to thank the PWI for the opportunity to provide this presentation. There are some animations in my slides, so I'm not sure how that's going to work with asking people to move slides from down there. Thank you. First off, I would like to say that Keith Middleton is a very brave man. Some of you were present when I spoke at the annual convention and mentioned some of the rather unusual practices of the esteemed Signal fraternity. Despite that, Keith allowed me to be let loose on the electrical discipline. I'd like to acknowledgement of country. So Rail Planning Service acknowledges the traditional custodians of country throughout Australia and recognises their continuing connection to land, sea and community. And we pay our respects to their elders past and present and extend that respect to Aboriginal and Torres Strait Islander peoples today. This slide sort of summed up what I think is my view of civil people's understanding of the electrical discipline. And I hope this will be your understanding after the presentation. So the journey is fairly extensive, and I know I'm keeping you away from drinking beers, so I'll be as quick as I can. So we'll talk about the rail as an electrical asset, the clearances from aerial high voltage wires for AS units, which will be an introduction to some of you, current leakage, pad mount transformers, earth grid mat security, insulation panels in fencing, bonding, stagger of overhead wiring, overlap or air gaps, impedance bonds, magnetic flux, dirty power, level crossings temporary and permanent, spark gap arresters, touch potential and intruders. This diagram shows the rail as an electrical asset, and most civil people don't understand that. So as an electrical traction system, one or both of the track running rails are used to provide a return path for traction current from the locomotive back to the substation, and also to provide electrical connections in the signalling track circuits to detect the presence of trains. This figure is a simplified sketch of a typical ballasted plane track, showing the rail and sweepers only overlaid with an equivalent circuit diagram showing key electrical parameters. The following series of slides provide some examples or some comparisons between DC traction system and AC traction system. So the DC traction system carries large traction return currents, which can be typically up to 2000 amps. For AC, typically the power supply is 15 kV or 25 kV, and the return currents are correspondingly smaller in an AC system. They both provide a return path for traction rail currents. They conduct signalling track circuit currents that can be mains frequency. For DC it's AC, for AC it's DC, audio frequency and impulse signals. The DC system overhead line equipment, masts are bonded to rail via spark gaps, which we'll talk about, which are voltage limiting devices to block stray current. In AC systems, the masts are solidly bonded to the rail. The higher currents of DC systems mean that such systems are more prone to spark erosion damage to the rail-headed insulated rail joints. AC systems are bonded to earth. The earthing systems are not ideal, and so under fault conditions, there can be a voltage gradient. We'll talk about the problems that that voltage gradient can cause later on. Minimum static clearance for DC 1500 is 150 millimetres. For AC 25 kV, it's 270 millimetres. They block signalling currents to prevent interference between adjacent tracks, while also allowing traction return currents to flow. The track support system formation insulate the rail from the earth in the DC. In the AC, the track is usually solidly earthed as is bonded directly to the high voltage traction earthing system. This means that in DC track system, the track is usually negative and the overhead wiring is positive, and the track is not usually earthed. So this means that in electrical terms, in DC, the track is floating, and there will be a voltage difference between the track and the earth, and the DC traction return current can leak out of the rails to the earth, causing electrolysis. And that's one of the major issues with DC traction systems. On the Sydney and Melbourne suburban network, the traction supply system is 1500 volt DC, and the substations are arranged with pairs of rectifiers that are rated up to 5 megawatts, and the traction return current's usually about 2000 amps. Now, I know that's pretty boring for civil people, but it will get a little bit more interesting later on. You just need to understand what the differences are between the DC and AC traction systems. They both block the signalling currents to prevent interference between adjacent track circuits. The track circuit system in the DC system insulates the rail from earth, and in the AC system it's solidly earthed. Sorry, it hasn't. A DC traction system requires transformers and rectifiers, or rectifier transformers. The AC system doesn't require rectifiers. In the DC system, the rectifiers produce other frequencies or harmonics besides the normal 50 Hertz, and these get transferred through the transformers into 11 kV, and that's what gets classified as dirty power, and that can also be a problem with DC traction. With AC, you require fewer substations, the overhead wiring structures are lighter, and hence the infrastructure cost for traction is usually lower, but not always. Because if you have a lot of bridges where you're electrifying with AC, you have a higher static clearance, so you have the extra cost in raising the bridges. And with the trains, if they're double decker, they're more expensive and complex, and you might have to remove passenger room in order to accommodate the equipment for the trains. Rail bonding. There's a whole lot of different types of rail bonding. There's flitch plate bonding. There's the jumper bonding to provide correct electrical connections for traction return. There's the cross bonding at regular intervals between substations to share the return current path. And there's spark gaps in DC traction systems to provide a turn path for fork currents directly to rail. Cross bonding. Due to the magnitude of the traction return current, the rails in multiple tracks are often cross bonded to each other, so that current is conducted back to the substation by all of the available rails and not just by the track that is carrying the train. Unfortunately, a lot of civil people don't realise that, and it can get them into trouble later on. The cross bonding has the effect of increasing the current carrying capacity of the traction return system, and can also reduce the levels of stray current adjacent to the track. So this is an example of North Sydney Station that was being upgraded to provide easy access. There was a power outage, there was a track possession, they elected the scaffolding on that section of track, and they wondered why the scaffolding started to grow red. The problem was they hadn't factored in the traction return current on the so-called dead track. So once they insulated the scaffolding from that particular rail, they no longer had a problem with red hot scaffolding. In electrified areas, before there is any interference with the rails forming part of the traction return, adequate provision must be made for a return path for the traction current to the adjacent substation or section hub. So you've got to be really careful that, just like with the North Sydney example, how's the traction return current getting back to the area that you're going to isolate, and you need to involve the signal people for the bonding to make sure that the signal circuits will work and the traction return can still work. Because if you cut the last section which provides the traction return, you can get a lot more sparks than you originally planned for. That's a bus bar with the overhead wiring negative connections to rail and substation. And again, you might be working on one section of track and you think that everything's okay, but you need to make sure that in some ways you're not affecting the adjacent section of track, which is still live, and might be used for traction return, and that can affect what you're doing on your section. So that's a diagram for stray DC current. The current leaves the track, goes into the earth, usually along the closest metal conductor, and then comes back to the rail, and that's where you get the corrosion, where the current returns back to the rail. Okay, stray current is a major issue, as I said, with DC systems, and the rate of corrosion for steel is equivalent to 9 kilograms of metal lost per amp of current per year. when your traction return currents are 2000 amps, you can see that that can add up to a fair bit of corrosion if you've got a large leaky system. Next slide, please. Back one. Okay, there's two methods for protecting against electrolysis. There's a cathode protection system, which you can see there, and also drainage bonds. Next slide, please. A spark gap is a device which provides protection against overhead wiring structures becoming live. It's a small cylindrical device which is fitted with two terminals. So you have one terminal fitted to the structure, one terminal fitted to the rail. If the structure becomes live, it short circuits, and that means that the structure is no longer live. And next slide, please. That's examples of spark gaps directed to an overhead wiring structure and to near a steel bridge. So spark gaps are put in all through the platforms and for 10 metres either length of the platform, because it's not a good idea to fry your passengers with a live overhead wiring structure. And they're also put near structures where, again, there's a possibility that leaking current can get into the bridge structure and cause problems. Next slide, please. The approach distance is pretty much the same for an ordinary person for both AC and DC. Next slide, please. Level crossings, you need to be careful, particularly if you put a temporary level crossing in, because it's often a ballast level crossing. And at Meeks Road, for instance, there's an access level crossing for rail staff and the area is electrified. So they have, no, back please. What you can see there is sort of the gauge hanging down from chains to make sure if vehicles go across the level crossing, they're well below the contact point for the live overhead wiring. Now you need to be careful if you've got a temporary level crossing and you often put a crane or something in before the possession starts. If they have a protruding jib, next slide please. Because with just a simple 15-degree incline, if you have a 2-metre jib extension past the vehicle, that means it's extra ½ metre in height as the vehicle goes over the temporary level crossing. And that's something that people often don't realise. Next slide, please. Now, before you were told that the metre distance was 3 metres, but the wires aren't stagnant, particularly in heavy winds. So if you're erecting metal scaffolding near overhead wiring, then the minimum clearance distance is 4 metres. There's the next part to this slide, that's it. Now, I don't know about you, but I have trouble judging distances in the air on just how many metres things are away. And what I recommend is what you can see there, which is flags or bunting that you put up as a clear distance underneath the overhead wiring to make sure if you've got vehicles or plant or other things going through that they're clear of the distance and they don't come too close to the live overhead wiring. Next slide, please. The other issues with you have trucks delivering, make sure that they don't keep their trays raised. Now that can depend on if the truckie's there and he gets paid for an hour, it's probably not a problem, but often they get paid per trip. So they're trying to minimise the quickness in how they get round, and you'll find that they'll be driving out with their trays raised, and that can be a problem on your site. Next slide, please. Traction bonding. The operation of the signalling track circuits relies on defined sections of track which are divided by insulated rail joints. The track circuits must be free of short circuits between when no train is present. The additional insulated joints can come into conflict with the requirements of the overhead wiring traction return, and that's why you have, next slide please, impedance bonds. So the impedance bonds used to be footed in the forefoots till we started ballast cleaning, and then we found they were a bit of a problem with the ballast cleaning chain. So they then moved them to the side where possible. And so that's the function of the impedance bond to allow the traction return to get around the signalling. Next slide, please. You also have temporary bonding and turnouts, because quite often you'll install a turnout, but it won't be commissioned. So to make sure the existing signalling works and the existing traction works, you may have to put temporary bonding on your installed turnout and then remove that when you commission the new system. Next slide, please. The overhead wiring is staggered, and the reason for that is so they can get even wear across the pantograph, because if you have fixed overhead wiring or there's not enough stagger, you wear a groove in the carbon strip on the pantograph. I know of one railway where the stagger wasn't quite right and they were wearing out the carbon strip within 6 weeks, which is not a good idea. So you need to make sure that stagger's right. And you also got to allow for blowout, but just like the the overhead wiring power lines, for the overhead wiring lines, they can move around in the wind. So there are tolerances for how much you can have blowout mid-bay. Next slide, please. Now this slide doesn't have any sound, it's in Russian. I purposely cut out the sound because I think it's mostly swear words. You can play the video and I'll talk. So after Granville, there was a special division set up on the Blue Mountains because they had some of the worst track in the electrified area. And so they upgraded the track, they removed the dog spike track, put resilient fastenings, ballasted it, tamped it, lined it. And when the first electric train ran, something like this happened. So there were some very red faces. And that was because they hadn't checked the stagger for the overhead wiring. Now, I don't know whether they pulled it to design line, which would have been against the structures, or they just smooth lined it because the track up there was so bad, the overhead wiring people may have adjusted the overhead wiring to the poor alignment anyway. So it's really important if you go and renew your track, you check the stagger for the overhead wiring, otherwise you can share those red faces. Next slide, please. Okay, there is a problem with intruders. So you can see on the left-hand side that's someone's version of intruder prevention with a bit of barbed wire and timber, but it's not really effective. Next slide, please. You can note the anti-climb spikes on this particular structure. There's a whole story about why the structure is leaning that way that we don't have time to discuss tonight. And I don't want to embarrass some of the people that may be present, but you can see how effective they would be. Next slide, please. The old style fencing on the left, just sort of mesh wire and barbed wire on top. Now I know of 3 fatalities associated with that type of wire. 2 were people that used bolt cutters to cut through the fencing and try and cut live cables. And you could say that's Darwin's theory of evolution in progress, I don't know. The other one, just hit it again, please, was a critter like this, who was a possum who became a very, very temporary live conductor in a substation and caused a major fire. So that's why you now have new anti-climb fencing around substations. Magnetic flux. When the train runs, the electric current flows through the motor cable and battery, and that generates magnetic flux. The magnetic flux is within the recommended limits for being associated with humans, and you can see the magnetic flux is different along the length of the train, and it's greater as the trains accelerate or as trains pass. So why is magnetic flux an issue if it's well under the limits? Well, it can cause interference with passenger information screens, and other sensitive magnetic devices like magnetic resonance imaging, other laboratory equipment. New metropolitan railways are often underground due to the high cost of land resumption in cities. Underground is also where much of this sensitive magnetic equipment is located to avoid interference from magnetic flux sources. So you might wonder, is that a problem? And in some cases it is. When you're doing a metro, you'll find you'll be going near a hospital or a research facility or something else, and then you've got to take special precautions about magnetic flux. Another issue is the overlaps or air gaps. Now, normally the contact wires run about 1 kilometre. It can vary between the railways as to just what distance they have, but you have to be careful that you don't have trains stopping for a long period of time near or those air gaps, and usually you've got to be 3 bays apart. Otherwise, you get a problem where the pantograph can go across 2 different sections and cause annealing of the contact wire, and it breaks. So that's an example there of what you have to avoid when you're doing your air gaps, and make sure that the signalling people talk to the electrical and vice versa. Pad mount transformer. When we were doing upgrading of a station up at Barara, was putting in easy access, and we installed a lift. And every time a train went past, people were caught in this glass lift and had to wait there for a couple of hours until a lift mechanic could turn up and free them. Now you can imagine that passengers weren't really happy about that. And the problem was dirty power, because I mentioned earlier the harmonics. So there's a lot of locations in the Sydney train system where you have this dirty power. So the project manager was told that if he fitted a pad mount transformer to remove those harmonics, that would fix the problem, and it did. But I'm told by more experienced people in this area that a simple change to the lift controller would also have fixed the problem. But you now have the standard where virtually every lift for an easy access station has a pad mount transformer. Now, there are issues with a pad mount transformer because they have an earth grid underneath. So you'll find that any fencing near a pad mount transformer has this sort of insulation panel and a sign on it saying do not connect to continuous fencing, because there's a concern that the fencing will get onto the earth grid and you then electrify a length of fence. And we now talk about FRAS units. Now, FRAS units are installed near high pressure gas pipelines or similar utilities to detect the presence of stray DC current. And there was an issue at Riverwood Station where they were doing some work on the bridge there, and they triggered the FRAS unit. And the problem, that's what the FRAS unit, that's the people working around it. And the trouble was that the fencing wasn't like that, but was like what you see on the right-hand side. So it was touching the building, and the fence on the left was also touching the building. And so you ended up with a 50 diameter hole, 50 millimeters diameter hole in 7 minutes because of the traction return current scraping. So it's pretty serious stuff, and it's even more serious. There's a whole lot of insulation panels put on the bridge and station since that happened, but only 5 metres from where that happened, there's a sign that says the high pressure gas pipeline. And a typical blast radius from a gas pipeline is 500 metres. Now, the blast radius can vary depending on the size of the pipe and the pressure of the gas. So that's why the FRAS units are there. So with the DC traction system, there are things that a civil engineer needs to be wary of, and railway people need to be wary of, because as I said, it can get you into trouble. There was also an incident up at Hornsby with high voltage wires. That was a substation that was being used as a store. There was using an elevated work platform to replace some fascia boards. There was a lessons learned circular developed because of the incident, and what happened is the elevated work platform got moved to let a vehicle go through rather than going back to its original position. The operator just raised it where it was, and it came close enough to the overhead wiring, and it sparked, and it just fried the elevated platform. Fortunately, the experienced carpenter on the elevated work platform used the fascia board to push the cables away from the bucket, because he knew that the circuit breakers would try and reset, and therefore they attempt to fry him again. That was very lucky for the apprentice that was with him. The other issue is that the vehicle tyres are smouldering, everything's frozen, and they're screaming out, you know, let us down. But fortunately, there were some senior people around who knew the dangers and didn't allow that to happen, because why the power is still connected to the bucket and the machine, sorry, you still had this problem I spoke about earlier about this radiant of the power. So if you step one step to the next, you can get electrocuted. So when they instruct people with using buckets and things like that and earth moving equipment, they say if you have an issue where the vehicle strikes power lines, you kangaroo hop. So you have your feet land together and you're not doing a stride, which can be enough to cause electrocution. So waited till the power was isolated, and then they could actually attend to the people that were stuck in the bucket. At MacArthur Station, again, doing up a station for easy access, putting in a turn back and some other things. The idea of touch potential wasn't really understood by all the different people working there. There wasn't coordinated design. There are a whole lot of people, different designers for different disciplines, kept adding to the station. So they weren't aware that the overhead wiring structures, you need at least 2 metres separation. You had canopy supports, you had lighting standard, you had line signed fencing, vending machines, ticketing machines, telephone booths, fire hydrant apparatus, CCTV, water pipes, which require insulated joints for the issue I spoke about DC traction return, metal canopies, handrails. Previous handrails were flush with the stairs for disability access. They're 0.8 of a metre extended. So that, again, needs to be considered. Drainage pipes from guttering and metal cabinets for disability access ramps. All those were fitted to this station, one after the other. So the solution was to cover the overhead wiring structures with plywood, paint it black and leave a little hole in the bottom so you could see the survey mark. Questions, comments and discussions. Questions and discussion I'll handle. Any comments you refer to Ian over there, because he knows much more about the electrical discipline than me.
I did notice the contact details on the edge unit.
Yes. Okay. Yeah.
Can we load the other presentation back up again, please? Thank you. Thank you very much, Mike, for your informative presentation there into electrical engineering, and it's great to be able to have now presentations of more than one discipline, so much appreciated. Again, thank you very much to Phil and his team from Effective Rail for the presentation earlier. We're just going to switch back to the previous presentation. We'll have drinks and nibbles available shortly for those that can stay. I think there's just a couple more slides just to go through to wrap up. We'll just try to reload those back up. We'll be with you in a minute. Oh, yes. Yes, please. Thank you. Sorry, John. We'll let John come up and use the. Thank you, John.
Well, good afternoon, everyone. I'm sure a number of you have heard about the Railway Technical Society, part of Engineers Australia. Back in 2006, the RTSA ran a study tour of Western New South Wales grain lines, because at the time the grain lines were deteriorating at a rapid rate. And Brian and I from the ARA said, we've got to do something about this, because if we don't do much, all the roads will start to deteriorate because the rails will not be used. And Paul Neville, the politician, had to do a report about the condition of transport from the country to the port, and the RTSA put in a submission for that. And not necessarily a result of that, a lot of money's now been spent on fixing the rails, and the Fixing the Country Rail project has been introduced certainly in New South Wales. They have problems in Victoria, but New South Wales, a lot of money's been spent on improving the access and the grain handling arrangements in the country. So much so that the RTSA is considering what we're going to call the Freight on Rail Development Study Tour, the Ford Tour. And the plan is to, after the convention in Orange, we're looking at having a 4-day tour in a coach that we're hiring from Parks to visit a lot of the facilities that are happening in New South Wales. The things such as in Dubbo, Mr. Fletcher's got a fabulous facility up there for handling grain and various other things. UGL are building the new facility for the new rail cars that are coming along. Parks, if you've been to Parks, you've seen the action out there on the Inland Rail. PN's got a new facility. SCT are out there. There's the Majinkable grain handling that's been there for quite some time. Out of Condobolin, we had a few washaways recently. We'd like to go and have a look at some of those. Down at West Wyalong, they've got some wonderful wheat handling facilities, and they've even got a depot down there that always seems to win the contests for the track repairs. There's various wheat handling facilities at Colleen, Ungary, Griffith. In 2006, we went over to Casella, the Yellowtail Winery. What a fabulous winery. You've never seen anything like it. They were producing 18,000 bottles an hour and shipping at 40 containers a day out of Griffith to the US. We'd like to have a look at that again. Round, yeah, we did get a free bottle of grog as well. Yeah, yeah. There's some new sidings being installed on the Journey Griffith line, and also the Inland Rail with the new facility, the new track that's been installed, and we'd like to finish it at June at the ARTC Control Centre. So the plan is that we'd have 4 days after the convention in October. So it'd be Saturday, Sunday, Monday, Tuesday. We've also got I've got a cousin who lives out at Kaikoura on the Ungarian-Aradan line. He'd be more than happy to entertain us again to show how the grain handling is carried out on that line there. So that's our plan at the moment, and I've got to discuss with Steve about what is being done at Orange with the convention. But after that, we'd like to organise this tour. So younger people especially would be most interested in seeing what's happened around the state and the facilities that are being built and used, and they really are being used. So that's the plan at the moment. So look out for information that'll come around. So it'll be a 4-day bus tour, and the plan's to stay overnight in Parks, West Wyalong and Narandra on the way to Junee. So that's the plan.
Thank you, John.
Good.
Thank you for that. I assume details for that will be available in the near future, will they, via the RTSA website? Was it the RTSA?
And the PWI as well.
Okay, great. Thank you for that. I know there's lots of activity on the CRN lines as well, and that's one of the reasons, obviously, we're going out to Orange for our annual convention. So just a reminder to all, our next technical meeting will be on the 8th of June, which will be our joint meeting with the IRC, and normal service hopefully will be back in full stead, Mark back. And the key upcoming events for your calendars is the PWI Winter Dinner. Tickets are available to book now, as I was told. Our annual convention, and then obviously the tour beyond, if those that want to attend, and a reminder about the Young Achiever Award applications. Oops. So, yeah, again, thank you very much, and please keep an eye on our LinkedIn for any updates that will be coming out on there, and obviously via the normal emails. Thank you very much. Again, I think at the back now, food and drink will be available shortly, so please stay if you can, enjoy and we'll see you again next time. Thank you. Oh yeah, just a little bit of support please if we can, just to help move chairs back to the side. Thank you very much.